I am going to demonstrate how the statistical analysis used in data science is similar to the math you learn in school, but is also different. The difference I will show you is the key to understanding practical data science work. Once you understand the key difference, you will be better prepared to communicate your results to others around you. Let us begin by recalling the formula for a straight line from algebra. Y equals mx plus b. In this equation, x is a variable, m is the slope of the line, and b is the y-intercept. We can picture this model on a graph with an x and y axis. All we need to do is plug in a value of x, and the equation produces the value of y. For example, if you are selling cloth by the yard, each yard costs $12 and the shipping cost is $10. The total cost of an order is y is equal to 12x plus 10. If we order 2 yards of cloth, the total cost is always $34. Let's keep the equation for a line but insert different notation typically found in the statistical models. Replace m and the b by the symbols b sub 1 and b sub 0. Nothing has changed here but the notation. Data scientists and statistical analysts use y for the outcome and x for the variables, but they use the letter b for coefficients in a model. Each b is giving a unique subscript. Moving on, let's change the order of terms and write the equation in a more conventional way. Y equals b sub 0 plus b sub 1 times x. So far, we have just translated the language of algebra to the language of data science. Next comes the difference that makes a big difference. In the world of data science and statistics, the formula for a line is just one part of a statistical model. Here, we have a statistical model that says the y equals b sub 0 plus b sub 1 times x plus epsilon. Why do we need epsilon? Remember I said before that every time you order 2 yards of cloth, it must cost the same amount. Why? Because the cost equation is a rule to follow. However, in a typical data science job, people construct statistical models of what they see. A statistical model has 2 distinct parts. The first part is the deterministic part of the model. That's the part that always gives the same answer. We can calculate it perfectly. The second part is the random part of the model. Some models have a small random component, and others have a very large random component. For now, let's just say that data scientists and statistical analysts spend a great deal of their time figuring out the sources of that random component. They dig into the data and create clever ways to reduce the random error in their models. To sum up what we've done, we can say that in data science we have one foot in the world of algebra and another foot in the world of uncertainty. You should be pretty good at math to do well in data science, but more importantly, you should also have curiosity, good observation skills, and common sense. This is why data science and statistical analysis are so interesting to so many people.